Okay, we are working with the law of sines, and in this example, we are given that angle C of a triangle is 39.2 degrees, side B is 29 units in length, and side C is 27.9 units long. And we're trying to figure out the rest of what's going on in this triangle. The other two angles, A and B, and the other side, little a. So we can start by setting things up with the law of sines with what we have here. So on one side we have little c, which is 27.9 over the sine of big C, 39.2 degrees. And on the other side we have little b, 29, over the sine of big B, which is unknown. We're trying to figure out what that is. Then by doing some solving there, we end up with that the sine of B is equal to 0.65694802 and so on. So B itself would be the arc sine of that number, which comes out to about 41.1 degrees. But remember when I said that for every acute angle in quadrant 1, there's an obtuse angle in quadrant 2 that has the same sign. So there's another possibility for what B could be, so that the sine of B comes out to be 0.65694802. And that is 180 degrees minus 41.1 degrees, which is 138.9 degrees. So there are two possibilities for angle B, and it turns out there are two different triangles that would fit the information that we were given. In the picture, I'm showing you both of them. One of them would be this angle here, from A to B to C, and the red line is one of the is the side C of that triangle. The other possibility is this little skinny triangle down here that goes from A over to B and then down to C. And the blue line would be side C of that triangle. In both cases, the length of C is 27.9. The length of B, well, it's the same side, it's 29. And angle C is 39.2 degrees. So what we have to do is work out both of these triangles. Possible triangle number 1 is where B is 41.1 degrees. Then once we have two angles, we work out the third by subtracting from 180 degrees. Angle A would be 99.7 degrees. And then we can use the law of sines, little a over the sine of angle A equals. Now we could use the B's or the C's, but it's probably better to use the numbers we started with than to use the numbers we figured out for ourselves, because the numbers we figured out for ourselves, we did round to the nearest tenth. And so to minimize round off error, let's use the numbers that we didn't do any rounding on. So that would be little c over capital C, 27.9 over the sine of 39.2 degrees. From that, we work out that A equals 43.5. So that was the big triangle where side A, all the way from here to here, was 43.5, and angle A was 99.7 degrees. The other possible triangle was the one we get if we take B to be 138.9 degrees. Then A works out to be 1.9 degrees. That's this really skinny angle here. And then side A, from the law of sines, turns out to be 1.5. We get this little tiny side across from angle A that has a length of just 1.5. Now let's look at another example where we have one angle and two sides. It starts out like the last one. We set up little c over the sine of big C equals little b over the sine of big B. Plug in the three numbers we have, solve for sine of b. We get that the sine of b is 1.05698 and so on. But here we've hit a snag. This is impossible. Sine can never be greater than 1. If you tried to ask your calculator for the arc sine of 1.05 something, it would give you an error message. So what that means is that this situation is impossible. There's no triangle that has these dimensions. And the way we knew was when we tried to follow the law of sines, we got a sine of b that was greater than 1. So as it turns out, anytime you have one angle and two sides, like we did in the last couple examples, there might be no triangle that fits that. There might be just one, or there might be two. And so in an actual problem like that, what we need to do is, first of all, figure out which of those it is. If there is just one triangle, find its missing angles and side. And if there are two possibilities, find them both. And the way to tell, I think the easiest way to keep track is just to start by being open to the possibility that there are two triangles and you're trying to find them both. And if you hit something that rules out one or both of them, then you can stop there. So start by assuming that there could be two triangles and you're trying to find what they could be. And sometimes you will get two triangles, sometimes you'll only get one, and sometimes you won't get any. So suppose little a is 15, little b is 25, and big A is 85 degrees. Plug those into the law of sines. You get that the sine of b is 1.66, and right there you can stop and say that's impossible, so there's no triangle that fits those numbers. Little a equals 22, b equals 12, and big A equals 42 degrees. Put those into the law of sines, and you get that the sine of b is 0.3648498, and so on. So far, so good. Now, b is either the arc sine of that number, which gives you the acute angle of 21.4 degrees, or you could also have the obtuse angle that's 180 minus that. 180 minus 21.4 degrees is 158.6 degrees. So far, we have two possible triangles, and we're going to chase each one of them down. Okay, possible triangle number one is where B is 21.4 degrees. Then C is 180 minus 42 minus 21.4, which is 116.6 degrees. We have two of the angles. We know all three have to add up to 180 degrees, so that's how we get the third. Then, once we have our big C, we can find our little c with the law of sines, putting that together with one of the other pairs. So little c over sine of big C equals little a over the sine of big A, and from that we get that c equals 29.4. So there's one possibility where B is 21.4 degrees, angle C is 116.6 degrees, and then side C is 29.4. What about possible triangle number two? That would be where B was 158.6 degrees. Then what about C? Well, that would be 180 degrees, minus A, which was 42 degrees, minus B, which was 158.6 degrees, but that comes out to be negative 20.6 degrees. Doesn't make sense to have a negative angle in a triangle. So right there we hit an impossibility. And so that second triangle, well, there isn't really a second possible triangle. So this is an example where there was only one triangle that fits these numbers. Let's try this. Little a is 12, little b is 31, big A is 20.5. Take these three numbers and stick them into the law of sines together with the unknown capital B. We get that the sine of angle B is 0.9047024 and so on. So B is the arc sine of that, which is 64.8 degrees, or it's the supplement to that angle, 180 minus that, which is 115.2 degrees. So we have two possibilities so far. They could both turn out to work. Possibility one is where B is 64.8 degrees, C is 94.7 degrees, and little c turns out to be 34.2 degrees, or 34.2 units in length. That's the side. Possible triangle number two is where B is 115.2 degrees. Then angle C would be 44.3 degrees. Side C, we work out with the law of sines. It turns out to be 23.9. And we haven't hit anything that doesn't make sense or doesn't work. So both of these are possibilities. There are two possible triangles that start with these three numbers. One of them has capital B 64.8 degrees, angle C 94.7 degrees, and side C 34.2. The other one has angle B 115.2 degrees, angle C 44.3 degrees, and side C 23.9. Another formula we get as a bonus with the law of sines is an area for any oblique triangle, that is, any triangle that isn't a right triangle, if we know two of the sides and then the angle between them. Like if we know sides B and C and angle A, or sides A and B and angle C. Where these come from is that the area of any triangle is 1/2 times the base times the height. The way I've got it drawn here, the base, the side this triangle is resting on, is side C, and the height is h, the perpendicular from angle C down to side C. And from what we were messing around with earlier, where we looked at just the right triangle on the left, we said that the sine of angle A is the opposite side, which is h, over the hypotenuse, which is b. So h is equal to b times the sine of A. So sticking that in for the height, the area is 1/2 times the base, which was C, times the height, which was b sine A. So that's this part of the rule. Area equals 1/2 times b times c times the sine of A. We could have done the same thing, but using either of the other two angles, and we would have gotten that the area is 1/2 times AB sine C or 1/2 times AC sine B. Either way, it's 1/2 times two of the sides multiplied together times the sine of the angle between them. So for example, what's the area of the triangle with side A equal 10, side B equals 7, and angle C equals 52 degrees? Well, we can just straight ahead plug them into this formula for the area. 1/2 times little a times little b times the sine of big C. That's 1/2 times 10 times 7 times the sine of 52 degrees. Again, make sure your calculator is in degrees mode, and you get about 27.58. Okay, I'll be back with one more video where I work you through a couple of application problems.